My name is Ernest Jordan. My presentation is on distributed systems. Distributed systems, thinking in terms of multiple computers linked together over networks so that no one person, no one computer has to be an island operating out all by itself. Certainly, great advantages to these systems. We have grown accustomed to them. You will hardly find a computer that is not somehow connected to a network. Even our cell phones feel useless unless they are online. So the files that we use are normally not local files. Many resources that we use are not local at all. When we experience failures, we hardly ever notice it because the systems that are in use are duplicated. As we discuss the distributed systems, again, we repeat that it's a collection of independent computers that appear to each user as one single system. The goals in designing a system that works is obviously, as we mentioned, the ability to share resources effectively. Transparency is important, reliability is important, and scalability. So we'd like to take some time to consider each of these areas and see what they mean, why they're important, some practical facts about each area. So again, resource sharing, access to remote files, devices, and computation. Remote printing is one of the easier things to mention. We've had that for quite some time. We've been able to access music. We're able to, with distributed file sharing systems, store our own personal files in a cloud. We're able to simply download what we need when we're even reading a book. Think about Kindle. We're able to process information on a non-local system and access that information on those databases. And a big thing that we are working with now are GPUs, graphic processing units. They're no longer just for gaming. As we process large data, perhaps getting into machine learning, deep learning applications, we need the robust ability of graphic processors so that your normal or regular CPU isn't overwhelmed and we're able to get all of that data, sift through it, talk about speeding up computations. Again, no longer are we tied to the CPU on our local machine. They can farm those computations out to remote sites. They could be working on the same project concurrently, distributing the various aspects of that one task and bring it all back together. It looks like it just all happened right there at our local workstation. That brings out the concept of balanced workloads. These jobs get moved to several different sites, could be anywhere on that network, perhaps even in another country. A true advantage to distributed systems. It's the new norm. Transparency does become an important subject because we want that feeling of everything happening right at our own workstation or our own handheld device, iPad or our iPhone. So we're able to log into systems, and it appears as if we're logged in from just a regular PC sitting there where all of the components are. And we just are able to keep that privacy. No one has to know our location. Working remotely is the way we do things now. And so whether we're on our phones, at a desktop, on a laptop, whether we're in an office, whether we're at home, sitting in our car, at the airport, on vacation, we can get our work done. And the beauty of the distributed systems is no one is the wiser. Another consideration with a system that works the way it's supposed to is reliability and robustness. Um, we mentioned failures. We can think about the work being done at one site, needing to go to another site because of a failure at one. Well, the system needs to be able to identify when a failure has occurred and be able to communicate that to the rest of the system to know we need to change to get whatever resources from an alternative site. It needs to be able to also report when the failure has been repaired and reintegrate the previous site back into the system. And it needs to happen pretty much transparently again. You need to be able to have as little downtime as possible. Robustness, how well is this system able to withstand failures in the first place? It's important considerations when designing a distributed system. But what does scalability mean? Scalability means the ability to handle more and more users. As more companies add individuals, or in fact, there are some supercomputers that are able to rent usage to individuals. So you have people from all over the world using these systems as shared resources. And the scalability says that we want that to be able to happen without overly taxing the system unnecessarily. So this computation, the power is being used by many individuals. The storage is great enough to handle whatever anyone wants to save. It's able to download that information back to the individual users, and the increased demand is able to be handled easily to accommodate all of the people that are using it. So as we think about the distributed systems again, we could get into the details of all of the protocols and naming conventions and things such as that. But this was just a brief overview of how we benefit from distributed systems, why we need them, why it is now the new norm. And so we looked at the challenges that individuals who are designing these systems must look at, and that's making sure it is able to provide the information. The resources are readily available. The transparency that we're able to work in any condition, situation, or mobility, and it seemed as if we're sitting there at an individual computer. And so we want to be able to privately be wherever we want to be. We want to be robust, a system that is able to withstand failures, effectively handle failures, and scalable. We need a system that is able to be able to grow with the increased demand